All right, um, we just have a little bit left on this. There's a couple things I want to show you on the calculator, and there's a couple problems I want to do. But then, so the rest of the time, that's your assignment that I told you I was going to assign after today. So if we have time, you can start it. We will have time, so you can start it. We don't have very much. Okay. This is so this will be 3.1 in our that we're covering right now. What we've been covering yesterday and today is 3.1 in your textbook. There's only two sections, 3.1 and 3.2. So we'll probably finish chapter 3 next week. Okay, we won't have a test on it next week, but we'll finish it next week. Probably have a test in the week after. So these chapters kind of go by fast because they're short chapters, a lot of them. So yeah, let's finish 3.1. So big thing takeaway. Correlation coefficient, also known as R, right? R tells us three things. It tells us direction, positive, negative, none. It tells us strength, right? Weak, moderate, strong, and then linear, right? It's always linear. So it tells us it's always going to be linear. It tells us how strong, and it tells us what direction everything's going, right? So if R is negative, like over here is R is negative, as X increases, Y is decreasing, okay? Same thing here, but not so much, not as strong, right? When R is 0, we don't know what's going on. As X is increasing, we don't know what's happening to Y. Is it going up, going down? Kind of, there's no correlation there. 0.6, dots are kind of moving on their way up, but not as strong as this guy here, 0.95. Okay? And so I gave you the number line to tell if it's weak, moderate, or strong. Okay? -1 and +1 are the extremes. For us to have a -1 or a +1, they would have to be either something like that, going uphill, and all line up perfectly. That's +1. -1 would look like that, or like this. Okay? Be careful with R. R is not slope. R is not slope. Some people think it's slope. It's not slope. Okay? R doesn't really have any units. There is no like inches, feet, miles, anything like that. R is just a number. It's one of the only things that we talk about that doesn't have any units. Okay? So we talked about that, and then we did a couple problems. So right here, we didn't get a chance to talk about this. Okay, so R, correlation measures the strength of the linear association. It's kind of, I don't know why that's there. Should be there. The strength of the linear association between two quantitative variables. Has to be quantitative. What is quantitative again? What's the difference between quantitative and categorical? Yes, numbers. Quantitative is numbers. Categorical is categories. Okay, still can be numbers, but you're fitting into categories. Okay, freshmen, sophomores, juniors, seniors, that's categories, right? The numbers, so we're just looking at sets of numbers. Okay, number 2, correlation makes no distinction between explanatory or response. So, for example, if I were to flip-flop them, take these guys and move them over here, and take these guys and move it over here. So take all of these and move them right here, and do the opposite. R would still be the same. The graph would look different. But it still would be the same R because strength is still the same. Okay. R does not change when we change the units of measure. So for example, instead of years, let's say I change this to months. Let's say, no, I don't want years, I want months instead. R would still stay the same. Okay. So yeah, so it doesn't change with units. Okay, but it does change with outliers, right? With outliers. So for example, this guy here, this would be an outlier if I had a dot up here. Why is that X an outlier? Okay, but you got to explain to me in context. In context. No, in context. What does in context mean? In context, though. What does context mean? When I say in context, what does that mean? Using the whatever they're using. So talk to me about years and talk to me about hours. So what you guys are saying, but use years and hours. Okay, go ahead, John. Yes, I will do that today. But can you tell me this? Why is that X in context an outlier? One second, what's it you? Yes, I know what you're saying. So kind of streamline that. This guy over here, is that too much time or too less time compared to the rest? Too much time, right? That's a lot more time than I would expect. This person right here, I would expect their time to be down here a lot faster. Okay, that's how you explain it in context. The X represents for that amount of years too much time. There's too much time. I would expect this person to live back in 1900 or 1910, right? But this person actually lives in 1980, right? That's in context. I talked about years. I talked about time. Okay, putting it in context. Okay, that's why it's an outlier. That's one example of an outlier. Let me move it. It's still considered an outlier. Why is it considered an outlier now? That's it. They were extremely fast in 1920, right? Before, right now, in 1920, the fastest time was up here. This person just crushed to that record. Okay? That's why they're an outlier. They don't fit the general pattern. Okay? So if I were to do that, let's say I were to do that. Let's say I were a guy right here. That would affect R. That would affect R strength. Might even affect the direction. Because R is how much of a straight line are those dots. So let me take away this guy. That's pretty strong, right? That R is pretty strong. It's a negative. We said strong, maybe moderate on the high moderate side. Maybe, maybe closer to 0.8, 0.7, 0.9, somewhere around there before, right? Or sorry, the other side, negative. Negative 0.8, negative 0.7, negative 0.9, around there, right? Well, what if I bring in this guy here? Now what R has to do is say, oh, I have to also. So before, they're all kind of trending in that direction, right? Now R says, wait. I also have to take into consider that guy. So R would pull away a little bit. R would probably pull away because it has to be closer to this guy. Because it says, R says this guy belongs with this group, but it's far away. So R would lose strength. R would definitely lose strength. It might even go to weak. Okay, it might even go to weak. Without that X, moderate to strong, probably in the strong category, right? But if I put an X out here, now maybe even weak, okay? So outliers. These guys right here are just multiple choice questions waiting to be asked. You guys know on multiple choice questions are the hardest ones on the test, right? They are. The ones where if you lose points, that's where you lose points at. Because there's no calculations here, right? It's either you know the stuff or you don't. So these are the kind of things that are super important. Mm-hmm. Well, it's depending what R is. I'm going to teach you how to calculate R today, and then I'll show you how to do it. That's what I'm going to do today. Today I'm teaching you how to calculate R, and based on where R lies on the number line, that's how we're going to describe it. Okay, that's how we're going to describe it. Okay, and then the one I skipped. R has no units of measure. R is just a number. It means something, but it's just a unit of measure. It has no unit of measure. Okay? All right. So how do we calculate R? That's the equation for R. But if you read in the fine print, luckily our calculators will calculate it for us. So we will never be asked to calculate R by hand. In this class, you do not have to calculate R by hand. Okay? If you were taking this class in college, they would make you calculate this by hand. Okay? So, but luckily AP says, nope, we don't care about you calculating the number by hand. We want you just to interpret it. Use your calculator and interpret it. Okay? So, but you do need to know who to find it, how to find it using the graphing calculator. Okay? So, if we have an assignment like we will today, and I'm asking you to calculate R, Mr. Flores, I don't have a calculator. Well, you can do it without a calculator. I wouldn't want to do it that way, but you can technically do it without a calculator. Okay? It just might take you an extra hour. Okay? So I'm going to show you how to do it today. Okay. So you go back to your calculator. Open up your calculator. Hopefully you have data in L1. So go to your list. If you didn't have the same calculator, it might, hopefully the person who used it yesterday left it in there. So when you put your calculator back in, since we have like numbers, they're all numbered. Since we got this new like case, it's padded and there's numbers. So it might not be a bad idea if you use the same calculator every day, put it in the spot, put it in the number, and you can get it so that it's really your calculator that you use. The only other people that use those calculators are my calc class, and they don't use it as much as we do. Okay. All right. So go to your list. Let's see, stat, edit. You should have two lists, hopefully. If you don't, these are the lists. This list is in your, it's from your notes. It was the backpack weight. It was backpack weight, and it's right here in your notes. So you can copy it from your notes. So if it's not there, L1 is body weight, L2 is backpack weight. Okay, so if it's not there, type that in. I want you to do is give the command to the calculator to show you a scatter plot. We did this yesterday, so see if you can remember. I want to see a scatter plot now. See if you can remember how to do it from yesterday. So if we want to see a scatter plot, what do we do? That's what I want you to do. I'll do it right now, but I want to see if you can do it on your own. Anytime you want a graph, we always go to stat plot, right? So it's second y equals. Okay. All the graphs for our class are located in there. Okay. So we hit the first one. Make sure it says on. This time for scatter plot, we want the first one, the one with the dots, the X and the Y with the dots. Okay. My explanatory is in L1, my response is in L2, and then mark, it doesn't matter how you mark it. That's just how you want to see the dots. Okay. And then you go to zoom stat, and there's your picture, right? That's what we did yesterday. Okay. So now what we're going to do is we're going to calculate R. We're going to calculate R. Okay. So to calculate R, we're going to go back to stat. So watch first. Remember, watch and then do. Okay? Because if I'm showing something up here and you're not seeing it, it won't make sense to you. So watch and then do. So go that. Okay. The next thing we're going to do is we want to calculate R. So we're going to go to calc. So go over one, hit calc. Okay. We're going to use, we've only used the top one. We've only used the top one of our stats, right? That's the only one we've used. But today we're going to use a different one. we're going to use number 8. Ln reg a plus bx. Be careful, there's 2 of them. There's one here with 4 ln reg ax plus b. That's not the one we want. We want the one that says a plus bx. We want the one that says ln reg a plus bx, this guy down here. That's the one we want. So you're going to go down there, down to 8. It's 8 on mine. Enter. Okay. It asks you again, where's your X? Where's your explanatory and where's your response? Same one, L1 and L2, right? Frequency list, don't touch it because we don't need it. Store, all it's saying is, do you want it to remember? Yeah, hit enter there, just hit enter. You can hit enter all the way down, and then it says calculate. So look at your calculator. It should say y equals a plus bx. It should say a equals something, b equals something, r squared, and r equals. Does anyone not have the bottom 2? Okay, I'll show you how to pull it up. So if you don't have the bottom 2, it's because your calculator hasn't been set to that. Some of them have been, some of them have. I'll show you. It's easy fix. Okay, so if you see exactly what I see, don't touch your calculator. You're good. If you see something different, I'm going to show you how to make these 2 guys appear. The last 2 guys, r squared and r. Okay, so this is what you're going to do. You're going to go down to your catalog. Catalog is every function that your calculator does. So if you look at the bottom of your calculator where it says 0, right above it says catalog in blue, right? That's what we want. Second 0. Second 0. Okay. Now this is the catalog of everything your calculator does. It's a long list of stuff. So we're going to go down till you hit the D's. Scroll down until you hit the D's. Once you hit the D's, stop. These are all the functions your calculator does. It's a catalog of functions. So it's a lot of stuff. Stop when you see diagnostics on and diagnostics off. That's where we stop. Stop where you see diagnostics on and diagnostics off. One more time. Stop when you see diagnostic off and diagnostic on. So if you didn't see R or R squared, you're going to turn your diagnostic on. Right now it's off. So how do you turn it on? You hit enter, 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 and it's done. Now go back and do the same thing we just did. So how do I get R? I go to stat. I go to calc. On. On. The one that says on. We want it on. What do you mean the one that says? Just the one that says on. Okay. Go down to ln reg, just like we did earlier. Enter, 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 calculate, enter. Now it should be there. It should be there. You should give you A equals, B equals, R squared equals, R equals. Okay. So now we know what R is. R is that number down there. So go write that number to 3 spaces. Write that number to 3 spaces. R equals 0.795. Okay. That's R. That's for the data that we had earlier. That's for this guy here. That's for this data here, right? Okay, so let's go to our number line now. Where does this fit on our number line? Like pushing up against the door of moderate, right? It's really moderate to strong. Now, if you say moderate, I'll give you credit because technically it's in there, but a better answer would be moderate to strong because that guy is about 5/10,000ths away from being in the strong category. That's pretty close. That's pretty close. So I would say, if I was doing this, I would say moderate to strong, because that's more accurate. Does it fit in the moderate category? Yes, but it's very close to the strong. So you want to be able to say that it's pretty close to strong. Okay, that's one thing. That's strength. What about direction? Positive. We know that because the dots are going up, and because R is positive. R is on the positive side. It's on the positive side, right? These are all the positives. Not on the negative side. Okay. Linear relationship. That's what we would say. That's how we would describe correlation or describe the association. We would say positive, moderate to strong linear relationship. Okay. All right. All right. So now what I want you to do, let's scroll down. Let's see. Okay. So last part of these notes for today. We're going to do another problem, and we are going to use a new set of data. New set of data. So let's do this one together. We'll do this one together because there's a couple things I want to show you. Okay, so where does the data come from? Where's the context? Following table shows the number of miles driven in thousands and advertised price in thousands for 11 used Honda CRVs from the year 2002 to 2006 model years. Okay, so a bunch of CRVs from 2002 to 2006. That's when they were new. So one of them had 22,000 miles on it. That's how much it sold for. One of them had 29,000 miles on it. That's how much it sold for. Okay, so on and so forth. So there were 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 cars. There were 11 cars. That's how much it was. Okay, what is the explanatory and what is the response? Don't automatically assume that the first one is always going to be explanatory. Sometimes the second one will be explanatory. Sometimes the first one will be response. Sometimes you just don't know. So looking at this, what do you think the question they were asking is? What do you think the question they're asking is? Looking at the data, looking at the prompt, what do you think the question they were asking is? Why were they getting this data? There you go. Yeah. How does miles driven affect the price of a car? Who was asking the question? I was asking the question. My mom, one of her old cars was a 2002 to 2006 CRV. She wanted to sell it. So she asked me how much she should sell it for. I created this data. This is the data I created years ago. Okay. Back when she had that car. So that's the question I was asking. That's the question she was asking. She's like, how much should I sell my car for? Okay. So I wanted to know miles driven. How much does that affect the price of a CRV? Now, these are all CRVs. I can't throw in a Camry in there or a Honda Civic and say it fits. It doesn't, because it's a different car. It's only for Honda CRVs from 2002 to 2006. Okay, when my mom bought the car, that's the year as it was. I can't remember what year exactly, but that's the year it was. Okay, so this data is not new; it's old, because used cars now are going for a lot more than that. Okay, but yeah, it's old. So because we're trying to see how miles driven affects the price, which one is going to be the explanatory? Price, not the price. Price isn't going to be explanatory. That's the response. We're trying to see what is the outcome. The outcome is price. Okay. If you're buying a car, especially used, New, not so much. New, they're all about the same price. Like if I'm buying a Honda CRV, they're pretty much going to be the same price no matter where I go. Maybe off a few $100s, but if you're buying a used car, there's a big difference between cars that are exactly the same, that have been driven, that are the same age and same car. One of the reasons is because of miles driven, how much they've driven it. Okay? So we would say explanatory. Miles driven. Price or response is price. Okay? So now what we're going to do is we're going to use the calculator to do a scatter plot, not by hand. We did one yesterday by hand. We don't have to do it by hand. Okay? So what I want you to do is make a scatter plot for this data here. You can erase the old data. We don't need the old data for the backpacks and the weights. We don't need that anymore. So use your calculator, show me a picture of this scatter plot, and I'll show you how to transfer it. So just get the picture in front of you. You don't have to draw anything yet. I'll show you how to draw it. So just get the picture of the scatter plot in front of you, and then I will show you how to draw it from now on. Okay. L1 and L2, that's your first step. Get your data in there. L1 is explanatory, that's the miles driven. L2 is your response. How much did it sell for? Then you're going to go to stat plot. Good, everything's good there. Zoom stat. And hopefully this is the picture you're looking at. Okay. So what we're going to do is we're going to copy this down on our paper. Okay. So let me get my So I'm going to draw an X and a Y. And then I'm going to draw where the dots are. Draw where the dots are. So there's 11 dots, so I should have 11 dots. So I'm going to try to draw them as best I can in the same general pattern that they're in. Okay, just in the same general pattern that they're in on your 11 dots, 11 dots. Okay. Now, I don't need the how to count, like when I did it earlier, I went by tens, I went by 20s. I don't need that. All I need is to tell me what is the x-axis, what does this represent, and what does this represent. I don't need numbers, just tell me what each of them represent. So what does the x represent? Miles driven. So I'm going to write that down. Miles driven. The units is miles. It's already said, so I don't have to write miles again. The other one is price. That one is in dollars. That's it. That's all you got to show. From now on, that's how you draw a scatter plot. You don't need to know. You don't need to do like we did at the very beginning where we're like that. Okay? If you're using the calculator, if you're doing it by hand, always like that. But if you're using the calculator and you're just trying to draw what the calculator is showing you, that's fine. I don't need the numbers. Okay? Just show me what the picture shows so I can see the trend. Okay? All right, so now what I want to do is I want you to finish it out. Do C and D. Do C and D. Okay, so 3 things for association: strength, direction, linear relationship or linear association. Those are the 3 things. So if this was a test question, you would have seen a 3 points right next to it because that's 3 things I'm looking for. Okay, so here we go. Strength. How strong would that be? Weak, moderate, strong, none? What do you think it is? I'd say pretty strong. I would maybe moderate to strong, but I would need to see. I would definitely think strong would fit, right? You know what strong looks like right here, right? This guy from your notes. This guy is strong. This guy is strong. I would say it fits strong more than moderate, but if you said moderate to strong, I'm okay with that. Okay. So strong or moderate to strong. Direction. Negative. Going downhill. Linear relationship or association. Okay. As miles is increasing, what's happening to the price? It's going down. Yeah. As miles driven gets bigger, price is going down. Makes sense, right? The more you drive a car, the less it's worth. Okay. If you buy a car for $30,000, you drive it off the lot, bring it back tomorrow, the next day, and say, I don't like it. The price is no longer $30,000. It's like $20,000 for that one day. That's why cars are probably the worst investment you can ever make. They get you from here to there. That's all, right? They're not investments means things that make you money over time, right? Real estate. If you buy a house now, 5 years from now, it's going to be worth a lot more. That's real estate. But cars will be worth a lot less money as time goes on, unless there are certain cars that rise that go up in over time, like classic cars, right? Classic cars, because those cars there's not very many of. There's limited amounts, right? But if I go buy a Honda Civic or a Toyota or a pickup truck or anything like that, brand new, over time it's going to decrease, depreciation. Okay, that's what cars do because they're making brand new ones as we speak, right? As we speak, there's brand new ones. So why would I pay you top dollar for your used car when I can just go down the road and buy a brand new one for the same price, right? Well, the last couple of years with the pandemic, that kind of changed, right? Because if I go to a dealership, it's like a ghost town. There's no cars there, right? So what happened was used cars started going back up. being worth more because I can't go buy a new one now. There's none there. So that means used cars started becoming more expensive. Okay? Right. It's called supply and demand. Supply and demand. The demand is there, but supply is not, price goes up. Okay? Okay. Last one. Find and interpret R. Okay, so now we got to calculate R. So let's go back to our calculators. That's my graph there. So to get R, stat, calc, linreg, not the first one, the second one. A plus bx, that's the one we want. Yes. Calculate, and then should be R. So R is negative 0.874. Okay. What's going on now? Why is that doing that? Okay. It was kind of a trick question. Interpreting R is the same thing as describing the association, right? So that number tells me I don't need a moderate anymore, right? Moderate, I don't need. Before, my eyes told me I might need a moderate, but now I have an actual number. So now that guy fits into the strong category. Strong, negative, linear association or relationship. Okay, it's kind of a trick question. C and D are kind of the same thing, but I asked them differently. I said, one I use association, one I use correlation, but they're essentially the same thing. The only difference is you had to give this number 2. That was the only difference, and you just use your calculator. Yeah, because they wanted to know, actually, they said find R. Find R, so we had to calculate it. Okay. And then interpret, that's my interpretation. Strong, negative, linear association or correlation or relationship, either of those. Okay. If it just said find R, then I would just need R equals negative 0.874. Interpret it means, what does that mean? Well, it goes with my number line. So it's in the strong, negative, linear relationship. Okay. All right. Okay. So we have about 15 minutes or so. I want you to start on your assignments. You're not going to finish it because we only got 15 minutes, but I want to give you that time to at least work on that. So please work on that. Okay. If you have questions, let's try to answer them now so that if you do it